Okay, you guys, we're going to finish the year with some radicals, and that is a skill that you do need to know for geometry. So we do want to start today with simplifying radicals. Radicals are the same thing as square roots. Well, you can have different roots, but we're going to talk about square roots in this class and in geometry. So you have a little bit of knowledge about that already, and we're just going to take square roots and we're going to make them into an equivalent form. That is a simplified form. So the first thing you need to know is that if you actually had, this is called the index, that's right in front of the square root right here, or the root. And then this is the exponent. Here is the base. It would be the same thing as if it was the base to the exponent over the index. So I know that sounds insane, but what that's saying is, like, if I wrote the square root of 25, and there is no exponent on the 25, so remember it's implied it's 1, that would be the same thing as 25 to the 1/2 power. They are equivalent. So if you ever see 25 to the 1/2 power, then that is the same thing as the square root of 25. Might be easier to think of it that way. And it says the index on the square root is invisible. What do you think that means the number should be? The number should be a 2. That's just the one we use the most often. You can have the cube root, which means what number times itself 3 times in a row. Like the cube root of 8 is 2 because 2 times 2 times 2 is 8. More than we need to know right now. But the big idea is that the square root of 25 is the same thing as 25 to the 1/2 power. Those things are interchangeable. Now you do have some knowledge of square roots. It just means if you see the square root of 16, it means what times itself, what number times itself is 16. And that number is 4. Another way to write this would be 16 to the 1/2. Okay, so the square root of 16 and 16 to the 1/2, the same thing. And then we know what number times itself is 16, that's 4. Here we have 50 to the 1/2. That's the same thing as the square root of 50. Same thing. Now, we don't know the square root of 50 to be a perfect number, but I do know the square root of 49, which is a little bit less than it, and I know the square root of 64, which is a little bit more, and the square root of 49 is 7. And the square root of 64 is 8. So my answer is going to be between 7 and 8. Because 50 is close to 49, it's going to be like 7.1 or something very close to 7. Same thing here. 33, the square root of 33 is 33 to the 1/2. And I know the square root of 33 is between the perfect square root of 25 and 36. So this is going to be between 5 and 6. And again, this is going to be a little bit closer to 6 because 33 is closer to 36. Finally, this last one would be 81 to the 1/2 power is the same thing as the square root of 81. And we do know a number times itself, that is 81, and that number is 9. Okay, so the big idea is that these are equivalent. The 1/2 and the square root. That's the big idea we're going to start with.